Bismillah wassalatu wassalamu ala rasulillah amma ba'd. Hello everyone, I am Mohammed Alhibshi, biomedical engineering student at King Abdulaziz University. Today I will present the MRI signal versus the magnetic field strength to see the effect of the magnetic field strength on the MRI signal. In MRI, a magnetic is one of the essential parts that produce the magnetic field, which are an important element that play a significant role in the MRI signal. And magnetic fields are essential for constructing a magnetic resonance images. The effect of the field on T1 and T2. Since the lemma frequency is proportional directly with the strength field B0, the MRI signal will be affected. The protons that have high mobility will not really affect T1 and T2 when the field strength change, but the protons that have low or intermediate mobility will make the T1 increase with the increase of the field strength. Some experimental measurements clarify this. We can see from the graph here on the left, the T1 value increase with the increases of the strength field in Tesla for the blood and gray matter and white matter. Same thing in the table on the right. We have in the first column the strength field in Tesla. In the second column we have a white matter, plus and minus standard deviation. Same thing for the third column, we have the gray matter, and the last column we have the blood. The T1 value of all these parameters are increasing with the increase of the strength field. For the strength field affecting the T2 value, the T2 will be a little prolonged when the strength of the field increased. In some cases, the value of T2 could be reduced and be more efficient at 7 Tesla or more. That could be seen in the next slide. Here in this table, we have the values of T1 and T2 of the rat brain, some part of the rat brain, as indicated in the first row. And in the first column, we have the strength field in Tesla, in 4 Tesla and 9.4 Tesla and 11.7 Tesla for both T1 and T2. For T2, we can notice that in almost all parts, after the 4 Tesla, the T2 does not change largely, or does not change as T1 changed. The effect of the field on signal to noise ratio SNR, contrast to noise ratio CNR, and relative contrast RC. To see the effect of the field on the MRI signal, 3 different magnet strengths are applied for the same body subject. The strengths are 0.5 Tesla, 1 Tesla, and 1.5 Tesla. But there are some points are taken into consideration before testing these strengths. First, same MRI machine are used to test the 3 strengths. Second, the test is applied on different body parts of the same person. Third, same imaging sequence with identical parameters are used without correction or correcting the repetition time of the field. Also, another thing, the receive bandwidth is constant, as well as the echo time. These are 3 pictures taken at the 3 different field strengths of the brain. The first picture at 0.5 Tesla, and the second picture at 1 Tesla, and the third picture at 1.5 Tesla. The SNR is increasing linearly with the increase of the field strength as the field strength square. There are some factors that cause the nonlinearity or flattening of the SNR and CNR from 1 Tesla to 1.5 Tesla. These factors such as radiative loss, radio frequency penetration, and cause quality. Moreover, the effect of the field strength is also seen on the relative contrast. As a result, the relative contrast is almost less dependent on the strength of the field, as will be shown in the next slide. Here we can see the effect of different strength of the field on the SNR. We can see that the SNR increased linearly as a square of the strength field from 0.5 Tesla to 1 Tesla. Then from 1 Tesla to 1.5 Tesla has an nonlinearity due to the factor mentioned before. Here we can see the effect of the strength field on the CNR, and we can see that the SNR also increased from 0.5 to 1 Tesla, and then has a nonlinearity or flattening due to the factor mentioned before, such as the coils quality and radiative loss and so on. Here for the relative contrast, we can see that the relative contrast is less dependent on the strength field and doesn't change so much. This is the end of this presentation. I hope you enjoyed, and thank you for your time.